Hello everyone. In this lesson, we're going to introduce the concept of what a complement is. So the definition of a complement of some event A, which we would write as either A with a tick or A with a capital C above the top, or even sometimes A with a dash, or sometimes you might see something like tilde with a A, or even something like this. And a lot of times which symbols you're going to see are going to be based on the context. I generally am going to be using the first two for this class. But the complement or some set A are just the outcomes that are not in A. So for example, if A is flipping ahead, the complement of that would be not flipping ahead or flipping a not head. If I'm drawing a card and I say the event is that it's a number card, the complement of it would be not a number card, meaning that it would be face cards or it would be an ace. So the reason I'm going to oftentimes refer to complements using the not term is because I want you to always be aware that when it comes to set theory and logic, which I'll define more in set theory later, is that the complement means whatever is not included, not that it's the opposite. And an example of this would be something like if I made the statement that everyone passes this class. Well, the complement of that, most people would say, if I asked you what's the opposite of everyone will pass this class, most people would answer, no one passes the class. But that's not true, because if you think about what the complement means, so a logical complement, meaning the opposite in a logical sense, would be not everyone passes the class. Meaning that all that has to happen is just one person not pass the class, and that makes that statement true. Right? So if I say everyone will pass this class, to disprove it, all you would have to do is show that at least one didn't. It could be one person didn't pass, or two, or three, or even everybody. So the complement is not whatever A is. Now, the thing about this is, because if you kind of think about all of the outcomes A, and I'm going to introduce Venn diagrams here, but I'll talk more about them when I do a set theory video. But if we have this diagram here that represents the space of all of our sample space, and we have some event A. The complement would be everything that is not in A. So this means that if I were to take the probability of A, I would get the probability of getting this, whatever is in here. If I take the probability of the complement, I would get whatever is out here. Well, if you notice, together, they make up the entire sample space. So this means that if I take the probability of some event A plus the probability of its complement, it will be equal to 1. And that is because A union A complement is equal to the sample space. And I will talk more about this in the set theory, but part of it. But for now, just know that this is called a union, and it can be thought of as an or statement. So if I say A or not A, this will be equal to the sample space. Similarly, if I said what is in both A and not A at the same time, that is to say A intersection and A complement, this would be equal to the empty set. So of course, if I took the probability of the empty set, so probability of A and not A will be equal to the probability of the empty set, which would be equal to 0. So this is where complements can actually be very useful. And this is actually all stuff that's used in, for example, in electronics. Every electronic device you use actually uses gates. And again, I'll talk more about that when I do an actual video just on set theory. But the idea of this is that you have some state. In this case, if you think of it in terms of electronics, would be an on state. Then the complement of that would be the off state. So zeros and ones. And this is actually how we can manipulate what happens within computer chips is using these different types of gates, which we'll talk more about later. But you have not gates, which are complements. You have or gates, which are unions, and you have and gates, which are intersections. And there's more from there, but those are the basis of electronics that we use every day, from your cell phone to your computer that you're watching this on probably. So let's do a quick example. The probability of obtaining a sum of 11 when rolling 2 dice is 1 over 18. So the probability that if I roll 2 dice and I get an 11 is 1 over 18. What is the probability of not obtaining an 11? So in this case, we would need to know the fact that the probability of not getting an 11 plus the probability of getting an 11 would equal to 1. And I know what the probability of rolling an 11 is. This is 1 over 18. So this means that this, whatever this is, probability of not 11, I just have to take 1 minus 1 over 18, which would give me 17 over 18. So that's how I could find that. And this is actually the beauty of using the complement, is because if you're looking at something of some event with its complement, because they will equal to all of the possible values, and they're also what we'll later on talk about, which is called mutually exclusive, this means that you can actually easily find one if you have the other, right? Because if probability of A plus probability of not A is equal to 1, then I want to find probability of not A. I can find that if I have the probability of A. Or similarly, if I want to find the probability of A, I can use not A by subtracting that probability from 1 and then get the probability of getting A. The next definition we have for this section are the odds of an event. So the probability of an event is the likelihood that it occurs. It is the number of outcomes in some event A over the number of the sample space, or the total possible outcomes. The odds of an event are a little bit different. So let E be some event defined on the sample space. The odds of this event, which are denoted as odds, or sometimes you'll see it written as a capital O, is the ratio of the probability of the event. So this is equal to the probability of the event to the probability of the complement of the event. So this is the probability that the event will occur to the probability that the event will not occur. So if you were to rewrite this in terms of our probability, this is going to be the number of event E over the number of the sample space to the number of the complement of E to the number of the sample space. Now, because both of these fractions are divided by number of sample space, we can actually get rid of this. And you could also think of your odds as the number of outcome E to the number of not outcome E. So an example of this might be, for example, whenever you're listening to people talk about sports, a lot of times they'll say, what are the odds of this? Or they'll tell you what the odds are. And if you ever look at something like sports gambling, well, the odds are basically the probable wins to losses. So for example, if the odds that a team will win are 3 to 4, this means that if they were to repeatedly play games, they would be expected to win 3 for every 4 that they lose, meaning that if they were to play 7 games total, they would be expected to lose 3 and win 4. So this is kind of another idea in terms of probability. So instead of just saying the probability that they win or the probability that they lose, it would be the probability that they win to the probability that they lose. So you can also think of this ratio. Because we have the probability of not E, we can replace that as it is the probability of E to the 1 minus probability of E. So if you only have the probability of the event, you could still figure out what the ratio is to get the odds, which is why sometimes this will actually be referred to as an odds ratio. Now, one thing I want to point out is it is always written as a ratio. So for example, even though sometimes we might solve it as a fraction, we always then need to convert it into a ratio. So it will not be, for example, 3 over 4. It's not 3/4, it is 3 to 4. So 3:4 is how we would write something like this. So the odds in favor of an event, so the odds of E, are the number of event E to the number of not E. If I wanted to get the odds of not E, then it would just be the number of not E to the number of event E. Okay, so odds are just, you can be thought of as the number of successes to the number of failures. So let's do an example. So in this example, given that the number of our event E is going to be equal to 3, and the number of our sample space is equal to 7, we want to find A, the number of not E, B, the probability of event E, C, the probability of the complement of E, D, we want the odds of E, and E, we want, again, the odds, but in this case, of not E. So the first thing we're going to do is we're going to figure out what are the number of outcomes in our complement of our event. So if there's a sample space has a number of 7, that means we have 7 total possible outcomes. 3 of them are our event E. So that means how many are left to be our complement or not event E? And that would be 4. And then that would be 4. And then from there, the probability of event E would just be the number of outcomes E over the number of outcomes in the sample space. Well, we have the number of outcomes E is 3, and the number of our sample space is 7. Similarly, if we have the probability of not E, this would be the number of outcomes in not E over the number of outcomes in the sample space, which we just said the number of outcomes in not E is 4, so this would be 4 over 7. And if we were to add these together, what happens? You have 3 over 7 plus 4 over 7 gives us 7 over 7, which means that it does equal to 1, which is good. That's what we want. So now let's talk about our odds. So your odds, if you remember, are the successes to failures. So in this case, it's going to end up being 3 to 4. But let's say we decided to use the probability definition instead. So we had that it was the probability of event E to the probability of not event E. So in this case, that would be 3 over 7 to 4 over 7. Which you can see, because they're both over 7, it's the same thing as just saying 3 to 4. Now the odds of the complement of E are just going to be those same ratio but inverted. So this is going to be 4 to 3. So if you thought of this, like, again, as a sports team, the odds that they win are 3 to 4. If they played 7 games, you'd expect them to win 3 and lose 4. The odds against them, so the odds that they lose, are 4 to 3, which means that for every 7 games, you'd expect them to lose 4 for every 3 that they win. Now let's do one that's the same idea, but just a little bit different. In this case, we are given the complement of E is equal to X. And the number of our sample space is equal to X plus Y. So now, in this problem, A is we want to find the number of outcomes in our event E. B, we want to find the probability of E. C, we want to find the probability of not E. D, we want to find the odds of E. And E, we want to again find the odds of not E. Okay, so now this one I know might throw people off a little bit because we're using X's and Y's. These aren't numbers anymore, but you could think of them as numbers, right? That's what they are. They're just numbers, but we just don't know what they are. We have the number of our complement is X. The number of our sample space is X plus Y. Well, if X of this, whatever the sample space is our complement, then what's left to be our not complement, our event, right? Because not double negative makes positive. So it would be equal to Y. So now that we have this, we can actually figure out what our probabilities would be. Because our probability of E is just going to be the number of outcomes E over the number of outcomes in our sample space. Well, we just said the number of outcomes E is equal to Y, and the number of our sample space is equal to X plus Y. Similarly, the probability of our complement would be the number of outcomes in our complement over the total number of outcomes, X plus Y. So we'd have X over X plus Y. So the odds of our event E, remember, is just the number of event E to the number of not E. Well, E in this case, we have a number of Y. And for our complement, we have a number of X. So this odds would be Y to X. And then the odds of our complement of E would just be the number of outcomes in the complement, X, to the number of outcomes in our event E. So let's do it with a more real-world example. Let's say that you roll a fair die. What are the odds in favor of getting a number less than 2? So if we think about a fair die, let's say we have the event A is rolling a die. If we were to roll a die, our sample space would be 1, 2, 3, 4, 5, 6. And our event is that we get a number that is less than 2. So if we consider numbers less than 2, is 1 less than 2? Yes. Is 2 less than 2? No, it's equal to 2. We didn't say less than or equal to. So our event E is just equal to 1 value. So the odds of this event occurring would just be the 1 outcome that is a success to the 1, 2, 3, 4, 5 failures. What about this next one? Roll a fair die. What are the odds in favor of getting a number less than 4? So in this case, let's call this one A. A is the event of getting a number less than 4. So we look at what are our possible values? Well, 1 is a value that's less than 4. 2 is a value that's less than 4. 3 is a value that's less than 4. 4 is not a value that's less than 4. So our event A would be 1, 2, 3. So the odds of getting a number that is less than 4 would be 1, 2, 3 successes to whatever's left, 1, 2, 3 failures, which then you could write, if you wanted to, you could rewrite as 1 to 1. Because oftentimes you will see places where you don't have to simplify them, but sometimes a lot of places will want to simplify them in terms of 1 to something else. They want to know the odds ratio of the success to the number of failures, where success would be 1, and then your number of failures would be some scaled score based on that. So that is it for odds. When we come back, we will look at tree diagrams, and then we will be done with section 3.1. Thank you for watching. To continue learning, click the linked video here for the next lesson. If there's a topic you'd like me to cover, let me know in the comments. Don't forget to subscribe, and I'll see you in the next video.